Tradebot Alpha is officially live, and he looks terrifying, cold, sharp, and exactly how I imagined him. I'm Captain Flasky Boy, a software developer and test with over 15 years of experience. I've tried trading stocks in the past, and more than once, I ended up holding the bags. So I thought, why not use my accumulated knowledge and build a Tradebot that can do the trading for me? First, we need to set up the project folder. I've created a new project called Pixel Tradebot Template. This folder is going to be the foundation for all the Tradebots I build in the future. It gives me a clean starting point. I can reuse every time I want to create a new bot. Next, I'm creating a new Docker file and starting to build the container. For the base image, I'm using Alpine. It is super lightweight, which makes it perfect for keeping everything fast and minimal. And finally, I'm wiring it all together so that as soon as the container starts, it launches app.py using the Python interpreter from the virtual environment for tracking and recording. And now, if we take a look inside Docker Desktop, you should see a single running container called Pixel Tradebot. Next, I started building out the web interface. To keep everything clean and organized, I moved the Docker file into a new folder called WebDoc, which will hold everything related to the front end. Inside it, I created two main folders, static for script.js and style.css, and templates for our splash.html file. The HTML uses Jinja templating to render a dynamic title and description, while Flask handles routing for the CSS and JavaScript. The JavaScript adds a simple splash animation, nothing too fancy yet, just a short loading sequence that transitions into a welcome message after 3 seconds. In the updated app.py, I set up a route for the route URL that renders the splash template. I also configured it to run over HTTPS using a local certificate and keys. Now, when I start the container in Docker and open it in the browser, Flask serves a splash screen that is styled, scripted, and ready to grow into something more dynamic. The template is starting to come together. It is not perfect yet, but it is already looking pretty solid. At this point, I'm getting bored of staring at the setup. So next we're going to focus on giving the Tradebot a face. Time to bring this thing to life. Now we're getting into the heart of the project, the Pixel Tradebot character. This is the soul of the whole experience, the thing users will see, control, and connect with. But before we can do any of that, we need a sprite, a pixel character, something we can actually build against. And not just any sprite. This one is a masterpiece, a pixelated beauty I created earlier, a handsome work of art that might even make Michelangelo stop and take a second look. To create my pixel characters, I've been using an open source tool called Piskel. It is lightweight, easy to use, and perfect for designing and animating pixel art frame by frame. One of the standout features in Piskel is its export options, especially the ability to export for PixiJS. When you choose that option, it generates both a sprite sheet and a matching JSON file that maps all of the animation frames. And that opens the door to something very cool. PixiJS is powerful, seriously powerful. It gives you hardware accelerated rendering support for movie clips, animation timelines, and it is built for performance. Once I saw how easily Piskel worked with PixiJS, I was very tempted to go all in. But there was one problem. PixiJS versions 7 and 8 rely on Node and NPM. That means pulling in a separate JavaScript package system and setting up a Node-based development environment. For this project, which is supposed to stay self-contained, portable, and Flask native, that stack just did not fit. The moment I realized it needed Node, the decision became obvious. As good as PixiJS is, it was not the right choice for this use case. So I took a step back and stuck with HTML5 canvas and vanilla JavaScript. That gives me full control and integrates cleanly into the Flask setup without adding extra dependencies. Even so, looking into PixiJS gave me a much better sense of how sprite animations can be structured and what is possible if I ever want to scale this into something much bigger. But for now, Piskel plus HTML5 canvas feels like the sweet spot. Simple, powerful, and perfectly aligned with what this project needs. To bring this character to life, I built a canvas-driven interface in index.html and connected it to a JavaScript file called app.js. This is where all the movement, logic, animation frames, and sprite handling is contained. Our character, Captain Flasky Boy, has 3 animation states, idle walking, left, and walking right. Each one pulls frames from its own sprite sheet, and I've wired an input detection so he responds to the arrow keys. There's even a floating animation that gives him a subtle hover. With the Flask backend securely serving the page over HTTPS and the canvas running the animation in the browser, we're now looking at a live moving pixel bot right in the center of the screen. Now things are starting to come together. We're not just moving a sprite around anymore, we're building a system, a smart system, one that can respond in real time. This is nice, but the goal was to control the pixel bot through an API, not through keyboard input and not with hard-coded logic, but by sending commands via a REST API endpoint. To make that happen, I created a Flask app called api.py. It runs inside Docker and has cores enabled so the browser frontend can communicate with it safely. The endpoint lives at /API/command, and for now, it returns a random direction left, right, up, or down. It also sends back short messages for the bot to say, this is only a test version for now, but later it will be replaced with real trading logic. On the front end, app.js is now calling the API every 2 seconds. When it gets a response, it updates the bot's direction and displays the message above the character. That gives us full control from the backend through the network and straight into the animation. And just like that, we have a working template, a Docker-based Flask REST API, talking to a pixel character on an HTML5 canvas. This is the foundation for every Tradebot I build from here. Right now, you can see the bot performing basic communication. It is simple, but it works. Later, I want this whole page filled with suggestions, reasoning behind each move, analysis, and performance stats. This is only the beginning. So now, we've got the template, the web interface, and the API all working together. But to really call this a proper template, it needs a face, it needs a stand-in, it needs an alpha. I need Tradebot Alpha. So let's build Tradebot Alpha. Tradebot Alpha is now live, and he looks terrifying, cold, sharp, and exactly how I imagined him. With that, the template is officially doing its job. We are now running two separate instances, one for me, Captain Flasky Boy, and one for Tradebot Alpha. Each instance has its own API, its own web interface, and both are running in Docker containers, completely independent, fully networked, and ready to run. And that wraps up the very first episode of the Tradebot series. We've built the foundation and brought two bots to life. We also turned this project from an idea into something real. It is still early, but the template is working, and that means we are ready for the next step. Thank you so much for watching, and I'll see you in the next episode. For now, enjoy the outro music. And if you enjoyed what you've seen and want to help keep this project going, consider supporting me on Patreon or buying me a coffee.